Now we will look at two kinds of observational studies that feature prominently in studies of risk of all kinds of undesirable outcomes, be it diseases or financial crisis. Two key concepts of this chapter are risks and odds. We will define the risk of such an uncertain condition as its rate in the population. So a risk is a number between 0 and 1, or between 0% and 100%. Table A categorizes a hypothetical adult population of 424,000 people by sex and by diabetes status. The rate of diabetes is 124,000 over 424,000, or 0.29 or 29%. We shall call the number 0.29 the risk of diabetes for the population. It is useful to compare risks across populations from different countries.
Suppose we take a simple random sample of 1,000 from this population.
Firstly, it is a random quantity, meaning if we repeat the sampling many times, calculating the resulting sample rate each time, these numbers will fluctuate, and it is impossible to predict exactly what will be obtained. Secondly, the sample rates will fluctuate around the population rate, which is 0.29 in this case. To know the diabetes rate, one has to test every one of the 424,000 people. A more practical solution is to take a simple random sample and to use the sample rate to estimate the population rate. According to the table, the risk of diabetes among females is about 0.33, while it is 0.25 for males. So females have a higher risk than males, and this fact can be summarized by a risk ratio. The risk ratio of diabetes between females and males is 0.33 over 0.25, and that equals to 1.33. This quantity is also called a relative risk. For accurate estimation of the risk of exposure groups, probability samples are practical due to the considerable savings in resources. We will consider two sampling strategies. The first takes SRS separately from the exposure groups. The second takes SRS separately from disease groups. We'll look at the pros and cons of the two strategies. Since in the population 1/3 of women are diabetic, we expect about 1/3 of the 1,080 sample women to be diabetic as well, which is 1080 times 1 out of 3, and that's 300. It turns out that 378 of the sample women are diabetic. The discrepancy with 360 is because of random fluctuation. So there are 702 healthy sample women. The row totals are fixed by the sampling method, but all other numbers will fluctuate around their expected numbers if the sampling process were repeated. The estimated risk for diabetes for females is 378 divided by 1,080, or 0.35, and the estimated risk for males is 53 divided by 208, or 0.25. The population RR is estimated as 0.35 over 0.25, and that's equal to 1.37. The estimates are very close to the respective population quantities. We conclude that simple random samples from exposure groups allows accurate estimation of population risk and RR, even if the fractions sampled are different among the exposure groups. The table shows the number of another study which randomly samples 5 out of 1,000 diabetic patients and 1 out of 1,000 healthy persons. The situation is similar to study 1 but flipped. If we try to estimate the risk, we get, for females, 364 divided by 506, and that equals to 0.72. And for males, 256 divided by 414, and that equals to 0.62. These numbers are not close to the population risk of 0.33 and 0.25. If the samplings were repeated, the calculations will still produce risk estimates that are too high. The current sample table cannot be used in the same way to yield good estimates of population risk and RR. Study 1 is an example of a cohort study. A cohort study typically enrolls subjects from different exposure groups who are then monitored for a period of time. Study 2 is an example of a case control study. A case control study enrolls subjects from different disease groups, so it is always conducted at the end of a time period. A risk is a rate, but more specific. Still, confounding is an issue. There can be a third variable associated. The risk ratio or relative risk is a useful measure of association. With a cohort study, population risk and population risk ratio can be estimated accurately from the sample table if the samples are selected at random. The estimation is generally not possible with a case control study, even with random samples. We have seen confounding as the main contrast between a randomized experiment and an observational study. Subjects in a randomized experiment usually do not resemble the population of interest. Extrapolation is also an issue for observational studies, since taking a random sample is a lot of hard work. More specifically, for a cohort study to accurately estimate risk, the sample should be chosen at random from the population.